Now we will see how to plot in Fluent. So in our problem, we have the requirement to plot velocity, temperature and pressure at D, 2D and 3D downstream location. This D, 2D and 3D means the center distance from the center is 1 diameter, 2 diameter and 3 diameter apart. So first of all, in the previous tutorial we created a plane and then we saw the contour plot. For line plot we have to create a line and then we have to plot our variables. So if you go here and if you go to graphics and animation and mesh and go to the display, you can see here we have a plane at the middle. We have a plane at the middle of the cylinder. So right now what we want a line on that plane. Let's say symmetric wall here. So we want a line in this plane at the downstream location at D distance from the center, 2D distance from the center and 3D distance from the center. Just like if you see here, if the cylinder is here, we want our line at D distance, at 2D distance and at 3D distance. So first of all we have to draw this line and then we will plot along this line. So let's begin with our line. So here this plane, the ISO value of z is 0. So any point on this plane the z coordinate is 0. So all we have to do, we have to change the x and y coordinate and then we will create a plane. If you go to geometry module, you can see here at the center plane our z is 0 because from the center z is 15 inch from the center in this direction and 15 inch in this direction, so z is 0. So in xy plane if we take a point here and here, we have to provide two coordinate, that is the x distance and the y distance, also the x distance and the negative y distance. So if first line is d distance apart from the center and our d is 2 inch, so from the center the x coordinate will be 2 inch, y coordinate will be plus 15 inch, and for this point x coordinate will be 2 inch and minus 15 inch. Let's see. So go to contour, new surface. You can go new surface from here or you can go to surface and here you have the options: isosurface, plane, line, points, everything. So go to line and it will ask you endpoints. So our z is 0, so we will select our z in both points 0. For x1 is 2 inch, x2 is also 2 inch, y1 for the first point is plus 15 inch and y2 is minus 15 inch. So we have 2 points. One point is x0, y0, z0, that is 2, minus 2, 15 and 0, and another point is 2, minus 15 and 0. So name it line 1, create, and let's see, go to mesh and select this line 1, display. Now you can see the line here clearly. So this line is 1d apart. Similarly, if we want to create a line 2D apart, we just need to change the X value, that is 4 inch. This is line 2, create, and select line 2, display. This is 2 inch apart. And for 3D, that is 6 inch. This is line 3, create and display. So these are the 3 lines we have created, and we will plot along this line for the velocity, pressure and temperature. Let's say we want a line in this direction, in Y direction, just like here, this line. So if we want a line in this direction, if you want to see closely, so we want a line along this line. So how we can do that? If you go to geometry module, you can see this point is our origin, and the X here is -20 and X here is +40, and Z is 0. Y is also 0 here, Y is also 0 here. So at this point, the coordinate will be -20, 0, 0, and this point the coordinate will be +40, 0, 0. So let's see. Go to surface, line. First point is -20, 0, 0. Second point is +40, 0, 0. This is line 4. Create, and we will go to mesh, and we will select line 4, display. Now you can see this is the line 4 along this line. So we will see the change of pressure, temperature and velocity along these lines. So let's do that. So go to plot, XY plot, go to setup. Now your Y variable, right now select velocity, velocity magnitude, and your X function is line 1. Plot. Now you can see a single line, Y. The thing is, the direction vector is X function, but your line is along the Y direction, right? So we need to change our direction vector from X to Y. So here our direction vector X equals to 1, change it 1 to 0 and Y equals to 1, and then plot. Now you will see the change of your velocity. If you want to see the velocity at line 2, plot, you can see the velocity at line 2. At line 3, plot, you can see the velocity at line 3. If you want to see individually, you can see individually, and if you want to see combinedly, you can see combinedly. So now let's say we want to see individually. So this is the velocity at line 1, so d distance apart, and we want to see the lines. So select the curve and pattern, apply, plot. This is the line, and for the axis we want float value for X direction and apply, and Y direction we also want float value, apply, and then plot. Now you will see a very nice curve. If you want to save it as a picture, you can save it as a picture in the same folder. Say velocity plot at D. Okay, now you can see the velocity plot. If you want to plot this in Excel file, you can also do that. So go to plot, XY plot, plot, this is the plot. Go to write to file, write, and save it where you saved your contours and pictures. Name it velocity at D. Okay, then it will save as a XY file. You can open it as a notepad. So here you can see the coordinate and the velocity. So if you go to Microsoft Excel and if you copy this from here, you copy this and you just paste it, and if you select all of this and go to insert plot, now you can see the plot in Excel also. So you can change, you can modify whatever you want and to make this plot really nice. If you want 2 or 3 lines individually or overlapping with each other, you can also write these 3 lines in a same notepad. So this is how we can plot. So this is for the velocity. So go to pressure, static pressure, plot. So this is the static pressure. Save it. Go to save and save it as pressure at D. So save it, and if you go here you can see the pressure at D distance apart from the origin at the downstream location. If you want to see the temperature, you can also see the temperature at line 1 plot. Here you can see the increase of free stream air temperature, which makes sense. If you want to see the temperature change, you can easily see how the temperature changes. The maximum temperature of the air goes around 317 degrees, close to the cylinder wall. So you can save it as this, name it temperature at D, 2D, 3D location. So if you go here, you can see the temperature changes at different location. You can also import these values in Excel. Now the interesting thing is we want to plot the temperature along line 4, which is parallel to X direction. So select line 4, temperature, plot. So this plot doesn't make sense. Why? So if you go here in the mesh and if you see this line is along X direction, okay? And if you go to plot and if you select this and plot, this will show you like this, because you can see the plot direction, the direction vector is now in Y direction. So we need to change this from Y direction to X direction and plot. Now you can easily see how the temperature changes. As you can see, from -20, that is the inlet temperature was the room temperature, that is 298, and when it gets to the cylinder, the temperature goes a very abrupt change to 353, and this is the cylinder wall which has no lines inside the cylinder. After that, at the downstream location, the temperature goes down and down. So if you want to see the contour, here you can see the same thing. So here the blue side is the low temperature, it gets hot and then after that it cools down. So this plot makes sense. So you can save it for future use. You can write it for data processing and other calculation. In the next tutorial, we will see how to calculate the surface heat transfer coefficient, the average Nusselt number, and the overall heat transfer. So you can see here the temperature change at the downstream location. You can modify this data, you can present it more precise way, in whatever you want. You can always do that when you have a saved data. So in the next tutorial we will see how much heat has been transferred and the heat transfer coefficient and how to calculate Nusselt number based on that.